So, hello and welcome to the third lecture on statistics, where we are going to introduce the probability mass function. So, we saw in the first lecture on this series, where we introduced basically the random experiment of the flip of a coin 2 times in a row, that the corresponding sample space is composed by either 2 times hats, first hats, then tails, first tails, then hats, or 2 times tails in a row. So basically in the first lecture we also summarized all the different elements where we introduced the random variables into a table, and we will take up the table from the first lecture here. So basically we recover the 4 different elements, so 2 times hats, hats and tails, tails hats and tails tails, and we introduced the random variable of the event of obtaining tails when flipping a coin 2 times in a row. So basically what we saw is that we can have like the element of the sample space where we have 2 times hats, so we have 0 times tails. So the corresponding random variable x equals 0 for 0 times tails. We can have first hats and then tails, or first tails and then hats, but in both situations we basically have 1 time tails, so x equals 1 for 1 time tails. Or we can have like the situation where we have 2 times tails in a row, so the corresponding random variable x equals 2 for 2 times tails. Then we also worked out the associated probabilities of the random variables, so p of x equals 0 for the first random variable. So we saw that this boils basically down to a counting problem. So we basically have 1 element here out of the sample space divided by the total number of elements contained within the sample space, which is basically 1 divided by 4. Then same for the random variable x equals 1. So probability of x equals 1. This time we have 2 elements in the out of the sample space, so we have here a 2. That again we divide by the total number of elements contained within the sample space. And of course the last element of the sample space, so 2 times tails in a row. So basically p probability of x equals 2 for 2 times tails is again 1 element divided by the 4 elements of the sample space. So basically what we have here is that we have the sample space here, all the 4 elements. We have x, the random variable, which is contained within the set going from 0 up to 1 up to 2, which is of course included in R, the total set of all real numbers. And of course we saw that if we take the probability of all the elements contained within the sample space, we have to end up at the total probability of 1. So we have the sum going from k equals 0 to 2, probability of random variable x equals k is 1/4 plus 2/4 plus 1/4, which of course is 1. So with this information we are now basically ready to introduce the probability mass function, which is the aim of this lecture. So probability mass function So the probability mass function is going to be a graphical representation, so a plot basically, where we have 2 axes. We have a y-axis and we have an x-axis. So on the x-axis we have the random variable x, and on the y-axis we have the associated respective probabilities. So p of x. So at the level of the random variables, we basically have 3 different values, 0, 1, and 2. So we are going to introduce these 3 values into our plot. So 0, 1, and 2. And on the y-axis, we have the corresponding probabilities, which is basically 1/4 for x equals 0, 2/4 for x equals 1, and again 1/4 for x equals 0. So now we are going to join the two values on the x and y axis. So basically for the first one, x equals 0, we have a probability of 1/4, so we are basically here. For the second one, x equals 1, we have a probability of 2/4, so we are basically here somewhere. And for the last random variable, x equals 2, we have again 1/4. So basically we are here somewhere. So for better illustration purposes, we can actually draw around a small box to visualize it, make it even more visible here. So small box, then we have the histogram style representation. So these are the three random variables with the associated probabilities. And what we see basically is that we have a symmetric situation around the random variable x equals 1. So all the information is already contained within this table, but the probability mass function basically helps us to illustrate or to have all the information at one glance. So in one plot we have all the information contained, and that's actually the beneficial point of having probability mass function. So this concludes the third lecture on statistics. So on the next lecture we are going to introduce the cumulative density function.